Hello all, welcome to Embedded Linux Learning Point, Linux from Scratch 11.1 episode 14. Now that we have toolchain, let's build the remaining temporary tools that we require. Okay, so now we start with libstdc++ from GCC 11.2.0 pos2. When building GCC pos2, we had to defer the installation of C++ standard library because no suitable compiler was available to compile it. As you know, when we're building for GCC pos2, we had uh, given a compiler option or the configure option to defer the libstdc++. We could not use the compiler built in that section because it is a native compiler and should not be used outside chroot and risks polluting the libraries with some host components. Approximate build time is 0.8 SBU. Required disk space is 1 GB. Installation of target libstdc++. Libstdc++ is part of GCC source. You should first unpack GCC turbo and change to the GCC 11.2.2 directory. Okay, now let's do it. As you know that now we have the uh, chroot environment having all these, I would say, uh, all these folders or directories, and the mnt lfs. This mount lfs has become the root directory for us now, so we can, and now all the packages would be present in the sources. So yeah, we have the sources here, and then we unpack with the tar command xvf gcc 11.0. Well, you know that this is a big package and it will take a few seconds to unpack or extract. So after entering the GCC folder, create a link which exists when building libstdc++ in GCC tree. Well, now we extracted it. Now let's enter change cd, change directory to GCC. Now we create a link which exists when building libstd++ in GCC tree. Okay, and create a separate build directory as we did before. So in order to build, we should have a separate build directory, enter to build. Then we make, oh sorry, before that we need to prepare Stdc++ for compilation, and these compiler options are libstdc++. Okay, C++ flag is -G02D genuine sources. These flags are passed by top level makefile when doing a full build of GCC. Host is your name, LFS Linux GNU. In our case is ELP LFS Linux GNU. And we have to mimic what would happen if this package were built as part of a compiler build. This switch would be passed to configure GCC's build machinery. Disable libstdc++ pch patch, I think. This prevents the installation of precompiled, okay, pch means precompiled, include files, which are not needed at this stage. Okay, Okay, it is checking. Let's check what and all it is configuring. Checking the configuration. x86 LFS GNU Linux G++. Okay, now that the configuration is done, we build using make. Probably it'll take some time. That's okay. Okay, it's 0.8 SPU. It'll take a couple of seconds. Well, and this is the stage where we are basically building tools for cross compilation. That means these are the this is the this is the tools basically GCC or libc++, which are compiled for the target using the host compiler. Okay, let it take some time. Let me try to rearrange my okay, it's not working. I don't know. The distro that I'm using is not that. Okay, let's see. This is how it go. Okay. The reason I'm doing this is because I want to read and execute at the same time so that we save some time switching. Well, this is okay now. Let's come to this guy. Okay, Okay, now it looks much better. Probably I can even uh, browse for something which I need during the build. Okay, now the build is done. Next we need to do a make install. Just trying to make sure that LFS variable is set. Okay, I think I have done something wrong. Let's check it. Did it say that I need to be, do I need to have LFS variable set or not? After the, okay, it's before entering the chroot. Okay, 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 need not to be, because if it is so, we would be using uh, LFS directory. Now we are in the basically LFS chroot environment. So that means we don't have to have this LFS variable set. That's fine. Okay, now let's move on to get text. Before that, we remove F, the GCC folder here. I'm sorry, we need to come back to stages and then to directories. Then remove from RF GCC folder. Okay, now let's extract tar xvf, then get text. Okay, the gettext package contains utilities for internationalization and localization. These allow programs to compiled with NLS native language support, enabling them to output messages in the user's native language. Okay, approximate build time is 1.6 SVU, 280 MB. Installation of gettext. For our temporary set of tools, we only need to install 3 programs from gettext. Prepare gettext for compilation. So let's go to gettext, then configure it for disable shared. Okay, we did not need to install any of the shared gettext libraries at this time, therefore there is no need to build them. Okay, let's just dive in to see what is the content of gettext. Okay, contents of gettext. It entails a lot of programs. AutoPoint, env subtest, gettext, gettext.sh. Okay, all of these programs, install libraries, install directories. That's fine. Let's just go through the short descriptions of it. AutoPoint copies standard gettext infrastructure files into a source package. Env subset, I think. Okay, substitutes environment variables in shell formatting string gettext that translates a natural language message into user's language by looking up the translation in a message catalog. gettext.sh primary serves a shell function library for gettext. Gettext, okay, gettextize copies all standard gettext files into the given top level directory of a package to begin internationalizing it. MSG attribute the filters messages of translation catalog according to their attributes and manipulates the attributes. Message catalog cat I think concatenates and merges the given .po files. MSG compare I think compares two PO files to check that both contain the same set of message ID strings. MSG com finds the message that are common to the given .po files. Okay, message converts a translation catalog to a different character coding. MSGen creates English translation catalog. Message exec applies commands to all translations of catalog and translation catalog. MSG filter applies a filter to all translations of a translation catalog. Message fmt generates a binary message catalog from a translation catalog. Message grep msg grep extracts all messages of a translation catalog that match a given pattern or belong to some given source files. Message init creates a new .py file initializing the meta information with values from the user's environment. Message merge combines two raw translation into a single file. MSG message unform fmt decompiles a binary message catalog into raw translation text. We'll pause it here. Here now we need to make. I hope this is the next step here. Okay, make. I know it'll take a lot of time. By then we just read through, understand what this get text package contains. MSG ununique unifies duplicate translations in a translation catalog. In getText displays native language translations of a textual message whose grammatical form depends on a number. Recode -sr Latin records Siberian text from Cyrillic to Latin script. Okay. getText extracts the translation message lines from a given source file to make the first translation template. Okay, this is the libraries. Defines lib as printf, defines auto printf class which makes C formatted output routines usable in C++ program for use with this strings and IO streams. Libgetextlib, a private library containing common routines used by the various gettext programs. These are not intended for general use. libgetextpo used to write specialized programs that process .po files. This library is used when the standard applications shipped with gettext such as message message compare, message attribute, message attribute and message gen, message English will not suffice. libgetextsrc, a private library containing common routines used by the various gettext programs. These are not intended for general use. text styling library. Preloadable libinit, a library intended to be used by LD preload that assists libinitl in logging translated messages. So let me do a little bit of Google search because what I feel is get text uh, is basically used for the language processing is what I understood. Get text package Ubuntu, maybe I'll go with Linux. Okay, it's from GNU. Usually programs are written and documented in English and use English at execution time for interacting with users. This is true not only from within GNU but also in great deal of proprietary and free software. Using a common language is quite handy for communication between developers, maintainers, and users from all countries. On the other hand, most people are less comfortable with English than with their own native language and would rather be using their mother tongue for day-to-day work. As far as possible, many would simply love seeing their computer screen showing not a lot less English and far more of their own language. GNU or GNU Get Text is an important step for the GNU translation project as it is an asset on which we may build many other steps. This package offers to programmers, translators, and even users a well integrated set of tools and documentation, specifically the GNU Get Text utilities are a set of tools that provides a framework to help other GNU packages produce multilingual messages. These tools include a set of conventions about how programs should be written to support message catalog or directory and file naming organization for the message catalogs themselves. A runtime library supporting the retrieval of translated messages and a few standalone programs to message in various ways. The sets of translatable string or already translated string. A special GNU Emacs mode also helps interested parties in preparing these sets or bringing them up to date. Okay, so as it is clear that it is a package which is basically used to basically translate from English to the native language. It is quite interesting to know that uh, when we change language, I think even uh, in the when you're working with Linux or we change the language when you install it will ask a lot of different languages that are supported. Probably it would use gettext internally. Okay, now the build is done. Let's install the getx package. We just need to copy the getx tools src to the user bin. Basically, we're going to use only these three packages as said before. Okay, perfect. Now it's done. Now let's build for Bison 3.8. So let's go back here, cd dot dot, and remove the get text directory, and then extract the uh, bison package. Then get to enter cd to Bison directory. Uh, okay, the Bison package contains a parser generator. Build time is 0.3 SBU. It will take 50. It requires 50 MB of disk space. Installation of Bison, the Bison compilation. So these are the configuration options. Okay, so the meaning of the new configure option. The doc directory. Here we use the user share doc Bison 3.8.2. This tells the build system to install the Bison documentation to a version directory. Okay, not the generic Bison directory. Okay, let's see the contents. Okay, Bison and YACC install programs and lib y.a short description. Bison generates from a series of rules a program for analyzing the structure of text files. Bison is a replacement for YACC, yet another compiler. Okay, YACC, a wrapper for Bison meant for programs that still call YACC instead of Bison. It calls Bison with the -y option. If you remember, we have done some linking with Bison and YACC before we start the LFS as an environment setup. Liby, the YACC library containing implementation of YACC compatible y error main function. This library is normally not very useful, but POSIX requires it. Okay, now that we know what it contains, let's build it. Since it is just 0.3 SPU, probably take less time. Probably uh, what I understand is Linux from scratch is more of you sitting and trying to compile the whole source code. Of course, at the end of it, you may not have, you could, but that's not the goal for us. You may not have a working Linux distro as such, but what you would understand is the internals, what it takes for a Linux system to build, what it takes to build a Linux system. Okay, then we have to make install stdl. Okay, it's installs, so that's the understanding. So basically we will know fairly what consists of your Linux and how to build a Linux system. Okay, now The package that we would install is Perl. We will remove the Python package from the sources, then extract the Perl dot. The Perl package contains practical extension and report language. Okay, Perl means practical extension and report. People would I have used Perl, but I didn't know that it means practical extension and report. That's great. Approximate build time is 1.6 SPU. Required disk space is 272 MBs. Installation of Perl. Prepare Perl for compilation. sh configure des. Okay, let's see the meanings later. Let's do this. Okay, it says it doesn't have sh, but why there is sh here? I don't know. But ideally for configuration, it should not use sh. Let me just do with, is it a typo? Let's find out. What I would do is I would just use the configuration instead of, let's see if it works. Okay, I'm stuck. Probably we are supposed to link this sh to bash. Probably. Let's see. Sh configure no such file or directory. Oh, sorry. We forgot to enter the Perl. Hmm. Now it should work. Perfect. Ah, I was literally taken aback that why it's not working. Hmm. It's my fault, not the book's fault, not typo. Sorry guys, sorry to LFS. That's okay. Mistakes happen. That's part of learning. Okay, so let's do this TES. This is a combination of three options. -D uses defaults for all items. E ensures completion of all tasks. S silences non-essential output. Okay. The others is the prefix, it's a user, and the vendor prefix is also user. Privilege, it's the Perl, whatever. This library is probably it should use core Perl library. That it is indicating that it should use core Perl library, and architecture library is also core. Then site library is site Perl. Site architecture is site Perl. The vendor library is vendor Perl, and vendor architecture is vendor Perl. Okay, fine. Let's see the contents. Okay, it also has a lot of tools or programs. Let's see one by one. The core list. Okay, now that it is built, if you compile Perl 15 on a different machine, different object directory, copy the policy.sh file from this project directory to the new one before you can configure. This will help you most with the policy. Okay, that's fine. Now we do make compilation. It will take a bit of time. That's okay. By then we will know what the contents of the Perl package is. Okay, the core list. A command line front end to module core list. cpan interact with comprehensive Perl archive network. cpan from the command line. enc2xs builds a Perl extension for the encode module from either Unicode character mapping or TCL encoding files. ENC guesses the encoding type of one or several files. H to PH converts .hc header files to PH Perl header files. Okay. H to hexes converts .hc header files to Perl extensions. INST mod sh converts shell script for examining installed Perl modules and can create a tarball from an installed module. JSON underscore pp converts data between certain input and output formats. libnetconfig can be used to configure the libnet Perl module. Perl combines some of the best features of C, Std, AWK, and sh into a single Swiss zombie language. Okay, got it. So it's more of a combination of C, Std, AWK, and sh. Like when you read a Perl program, it looks very syntactical. I would say it is it is quite powerful, but for a beginner, it is difficult to understand. What I know is, at least from my experience, Perl has a steep learning curve with respect to syntaxes. How do you use regular expression or glob? It looks like everything looks like regular expression in Perl for me, especially. Anyways, Perl 5.3.334.0, a hard link to Perl. Perl bug used to generate bug reports about Perl or the modules that come with it and mail them. Perl doc displays a piece of documentation in pod format that is embedded in the Perl installation tree or in Perl script. Okay. Perl IVP, the Perl installation verification procedure, it can be used to verify that Perl and its libraries have been installed correctly. Perl thanks used to generate a thank you message to mail to Perl developers. PyCon Perl version of the character encoding converter icon. P icon. Okay. PL to PM, a rough tool for converting Perl 4.pl files to Perl 5.pm modules. Pod to HTML converts files from pod format to HTML format. Pod to man converts pod data to formatted dot or rough input. Sorry, star dot rough input. Pod to text converts pod data format to ASCII text. Pod to usage prints usage message from embedded pod doc in files. Pod checker checks the syntax of pod format documentation files. Pod select displays selected section of pod documentation. Pro- Proof command line tool for running tests against the test harness module. tar a tar-like program written in Perl. Okay. Ptar-diff, a Perl program that compares an extracted archive with an unextracted one. Ptar-grep, a Perl program that applies pattern matching to the contents of files in a tar archive. SHA-SUM prints or checks. SHA checksums. Spline ls sorry ls is used to force verbose warning diagnostics in Perl. X sub pp converts Perl access code to C code into C code. Zip details displays details about internal structure of a zip file. There is so much to Linux. That's what I understand. Okay, let's wait until the build finish. Okay, now the build is done. Let's install this. Okay, we have installed the Perl package. Next, we will move on to Python. We will remove the Perl source files. Then tar x xvf xvf python. Okay, Why we have docs? Quit. ls-l. Let's see where the Python is. Oh, ls. Okay, that's fine. Let's do an ls. Okay, Perl, Python, docs HTML. The Python 3 package contains Python development environment. It is useful for object-oriented programming, writing scripts, prototyping large programs, or developing entire applications. There are two package files whose name starts with Python. The one that the one to extract from is Python 3.10.exec. Okay, let's extract this tar-xvf. Let's see. Okay, perfect. Then cd python. Okay, it starts with capital P. That's the reason I missed it. Fine. Then prepare Python for compilation. Okay. So Python now it's a very popular programming language. Probably not many people who have built Python from C source code and executed Python programs. Let's see. I mean, we are building Python 3.10.2. Hopefully, when the LFS is finished, when we're able to, I don't know if it succeeds, but hopefully, if we're able to build our own Linux, and we will try to execute some Python program, at least hello world Python program. Meaning of these configurations: enable shade, this which prevents installation of static libraries, and without ensure pip, this which disables Python package installer, which is not needed at this stage. Pip is uh, package installer for Python modules. Okay, we will compile using make. So it would take around 1.2 SBU. So it is a bit of time in my computer. That's okay. But some Python 3 modules can't be built now because the dependencies are not installed yet. The building system still attempts to build them, however, so the compilation of some files will fail and the compiler message may seem to indicate fatal error. The message should be ignored. Just make sure the top level make command has not failed. Optional modules are not needed now and they can be built in chapter 8. Okay, this is a temporary build, I would say. The contents of Python 3. Okay, 2 to 3, idle, pip3, pydoc3, python 3, python 3 config. Okay, 2 to 3 is a Python program reads Python to run X source code and applies a series of fixes to transform it into a valid 3.x code. Okay, idle 3 is a wrapper script that opens a Python aware GeoEditor. Idle is an editor, Python editor. For this script to run, you must have installed tk before Python so that the tkinter Python module is built. pip3, the package installer for Python. You can use pip to install packages from Python package index and other indexes. PyDoc3 is the Python documentation tool. Python 3 is an interpreted iterative object-oriented programming language. Okay, it is Python is building. So my experience with Python is like I have used a scripting or programming language. Normally, I use Python for automating tasks and interpreting data, or let's say plotting data, data visualization. So Python is really a very, I would say, extensive language. You can do many things with Python. That's all I can say for now. But these days, Python is a very basic need for any programmer, even for embedded systems programmer, I would say. You must have Python under your belt to really do well in your career. Okay, the compilation is done. Then we do make install. Okay, now Python is installed. Let's go to next package, text info. So I will come back from source, remove the Python directory -rf recursively faucet, and then tar xvf, extract the text info package. The text info package contains programs for reading, writing, and converting info pages. Okay, then cd text info. Then you have oh, installation of text info. The first fix an issue, building the package with GCC 2.3.4 later. Okay, cd. This is basically we're gonna, I think, eliminate this and insert this. Okay, that's fine. Not eliminate, insert. I think SED options. Let's just Google it. SED-E text editor. Options. What are the options? Let's go to options. Option. Okay. Set examples. Okay. Let's just get into it. Probably it doesn't explain what the IE and I is for. Set option list. All that I need is a list. CD scripting. We should use F option before the script file name. Blah blah blah. Okay. Not much info, but in the interest of time, I will move on. But anyways, we can learn more about SED in case we need it in the future. So then the step is for configuring. It says it's 6.2 SPU, means it will finish in a couple of seconds. Contents of text info. Okay, let's not get into this. Contents of text info. Okay, it has info used to read info pages, which are similar to man pages, but often go much deeper than just explaining all the available command line options. Okay, for example, compare man, bison, and man. Okay, info bison. Okay, it's like that. It's basically for the info of a particular command. Now we will make for the build install info, used to install info pages. It updates entries in the info index file. Make info translates the given text info source documents into info pages, plain text or HTML, PDF text to DVI used to format the given text info document into a portable document format PDF file. The port to text I converts port into text info format. Text I to any translates text info source documentation to various other formats. Text I to DVI used to format given text info document into a device independent file that can be printed. DXI to PDF used to format given text info document into portable document format file. Okay, are the same? No, it's different one. I think it does PDF text info to DVI. I think it will convert PDF to text info format. Sorry, DVI format. Device independent file format. Okay, now let's install this package. Make install and then text index is used to sort text info index files. Okay, that's it on the text info. Now is util Linux. Then I'll come back to sources and then remove rftx info. That's okay. Now let's star -x vf util Linux package. Okay, the util Linux package contains miscellaneous utility programs. Then cd to util Linux. It will take 0.7 SPU, 129 MB is required. Installation of util package. We need to create the FSH file, FHS file hierarchy standard recommends using the var lib hardware lock directory instead of the usual etc directory as the location for the edg time file. Create this directory with make dir -pv var lib. Okay, we got to create this directory. Created. Prepare for compilation. Okay, the meaning of the configuration options are edg time path. This sets the location of the recording information about the hardware clock in accordance with the FHS. This is not strictly needed for this temporary tool, but it prevents creating a file at another location, which would not be overwritten or removed when building the final util Linux package. The libdir is user lib. This which ensures the .so symbolic link, symbolic targeting the shared library file in the same directory, user lib directory. Okay, now the configuration is done. Let's build it with make. Then disable star because it's disable a lot of different things. Switches prevents warning about building components that require packages not in LFS or not installed yet. Login, no login, issue, switch user. Okay, set private, I think, run user. Okay, all this is fine. And without Python, this switch disables using Python. It avoids trying to build unneeded bindings. Run state dir. You can run this, which sets the location of the socket used by UIDD and libuid correctly. And we are compiling it. Let's see the contents. Okay, the utility Linux contains a lot of programs. It has these libraries. It has a couple of directories installed or created. Okay, well, we will go through this. It's a big list, but anyways, since the will take some time, let's go through them. EDTR part informs the Linux kernel of new partitions. Okay, HTTY opens a TTY port, prompts for a login name and then invokes a login program. BLK discard discards sector on disk. BLK is a block discard. Block ID recommend a line utility to locate and print the block device attributes. BLK zone runs zone command on the given block device. Block dev allows user to call block device IOCTLs from the command line. Cal displays simple calendar. CF disk manipulates the partition table of the given device. I think we have used CF disk when we partition for LFS. CH-CPU modifies the state of CPUs. CHMEM configures memory. CHOOM displays and adjusts OOM killers score. CHRT manipulates real-time attributes of a process. COL filter out reverse line feeds. Call CRT filters in and rough output of terminals that lack some capabilities such as over-striking and half-lines. Call RM filters out the given columns. Column formats a given file into multiple columns. CTRL control alt delete. Okay, control alt delete. Sets the function control alt delete key combination to a hard and soft reset. Del part asks the Linux kernel to remove partition. Dmessage dumps the kernel boot messages. Okay, now the build is done. We do make install eject removes media, allocate relocate space to a file, fdisk manipulates the partition of the given device. Okay, it has different programs. Since the interest of time, I will not read out the whole thing, but it is kind of utility we normally use in, let's say, command, a shell script or a command utilities. You see, we have used skill last, ls look. Okay, ls block displays the uh, block symmetry format. Okay, mkfs. I think you'll have more mount point name I. A lot of utilities which we normally use to interact with Linux. You need these utilities. You mount for unmounting UID, a daemon used UID library to generate time-based UIDs in a secure, granted unique fashion. Okay. Okay, so now I will not read out. That's fine. And the next is we have finished the building of the utilities. Probably this is okay for this episode. Let me just check how much is remaining in this chapter. Okay, let me finish this chapter by completing the whole steps in this chapter. Well, the next thing what we do is I'll anyways come back cd and then remove the util linux source files. Okay, next is cleaning up and saving the temporary system. Cleaning. First, remove the currently installed documentation to prevent them from ending up in the file system. Say about 35 MB. Anyways, that's okay. We'll remove it. No harm in it. Second, the libtool, the .la files are only useful when linking with static libraries. They're unneeded and potentially harmful when using dynamic shared libraries, especially when using non-auto tools, build systems while still in chroot. Remove these files now. Find user remove these files. So what it does is finds these libraries and deletes them. The current system size is now about 33 GB. However, the tools directory is no longer needed. It uses about 1 GB of disk space. Delete it now. Okay, what I will do is let's go back to cd dot dot. Is there a way to find out how much L? Okay, so LK. How do I list? This is basically the memory. What it says, I think it's in MBs. Okay, probably it says it's about 3 GB. How do I know it? I think yes, I can know this with file manager, I believe. Let's go file system. Here we have user various amount. Okay. Now I am with ELP. Maybe that's the reason I'm not able to see that mount LFS. Hmm. Okay, that's fine. Sorry, it's here. Mount LFS. We have these things. Now let's see the properties. Yes, totaling of 3.3 gigabits, gigabytes it has. Hmm, that's fine. What I'll do is we will delete the tools. That's fine, hopefully. It's deleted. And now let's come back and see if there is a tool. No, there is no tool. Now let's check the properties. You see it became 1.9 GB, so around 2 GB. That's fine. Let me close this. Fine. Then backup. At this point, the essential programs and libraries have been created and your current LFS system is in a good state. Your system can now be backed up for later use. In case of fatal failures in the subsequent chapters, it often turns out that removing everything and starting over more carefully is the best option to recover. Unfortunately, all the temporary files will be removed to avoid spending extra time to redo something which has been built successfully. Creating a backup of the current LFS system may prove useful. Note: all the remaining steps in this section are optional. Nevertheless, as soon as you begin installing packages in Chapter 8, the temporary files will be overwritten. So it may be a good idea to back up the current system as described below. The following steps are performed from outside the chroot environment. That means you have to leave the chroot environment first before continuing. The reason for that is to get access to file systems located outside the chroot environment to store or read the backup archive, which would not be placed within the LFS hierarchy for safety reasons. If you have decided to make a backup, leave the chroot. Okay, now we will read, we'll exit the chroot and we are back with mount LF, we're back with the root user. All of the following instructions are executed by root on your host system. Take extra care about the commands you are going to run, as mistakes here can modify your host system. Beware that the environment variable LFS is set for LFS by default but may not be set for root. Okay. Beware that the environment variable LFS is set for user LFS by default but may not be set for the root. So ELP, so let's see, echo LFS. It is set. Okay, so what I normally do is, okay, so since I'm using a virtual machine here, I would, at this point, I would take a backup of the virtual machine itself. So in that case, my system would be here. So I'll go back to my virtual machine and take a backup. But anyways, here he says something important. Let's see, which we had done earlier. Setting the LFS variable. Okay, export. Anyways, we have it here. Mount LFS. Blah blah blah. Section 2.6. This is section 2.6. Throughout this book, the environment variable LFS will be used several times. You should ensure that this variable is always defined throughout the LFS build process. It should be set to the name of the directory variable. Okay. If you're building LFS in a separate partition, this could be the separate mount point, that's fine. Having this variable set is beneficial in that command, such as mkdir lfs tools. Okay, fine. Edit the poshback anyways, that's fine, that's fine. Okay, now at least I have this mount LFS. I think I'm in a good shape. But anyways, what I will do is I will take a backup of the whole system. So I followed the command to take backup. So sudo tar, basically this is the command to take a backup. Now I have a backup available here, the tarball file. I think I am good to go. So probably in the next episode, I will start with building the LFS system with the available tools we have built in this series till now. Please subscribe to this channel. If you have any feedback or suggestions, please leave in the comment section. Thanks for watching.